Greetings from Pompeii. I'll be spending a couple more hours gathering data tonight. Last night, 12 hours worth of data gave us a very nice plot of the Milky Way. I'm going to pull it in just 1 second. Actually, we can pull it here. This is looking at the data from last night. And that's what we ended up with. Don't know what these are. Aha, okay. Very good. So right now I started capture at noon. And we're going to go till tomorrow noon, so we'll have 24 hours of the Milky Way passing overhead. Well, 24 hours of the Milky Way. One lap of the Earth. That's another way of looking at it. Not as pretty. So I'm going to stick with the traditional default. Hello, Michael. Okay, the wind down. I was able to capture 12 hours worth of data from 6 p.m. to 6 a.m. yesterday. Processed the data, post-processed it, and this is what we came up with. Those two peaks are indeed the Cygnus arm and the Perseus arm of the Milky Way. I'm still trying to understand what everything means here, but these are a couple of programs written and provided by amateur astronomers that I was able to use directly on the SDR sharp data to extract, to convert the files into these drawings. Certainly pretty, so I'm gonna take that. Plan for tonight is to watch the hydrogen line for a couple of hours and then wind down for bed. I'm capturing 24 hours worth of data. Started at noon, it'll end tomorrow noon, and then we will plot it and see what that gives us. I suspect it'll be very similar, but with a much longer time frame. To the left here, these are the frequencies, 1.42. These are the magnitudes. And these are the hours, the 12 hours that we captured. 3 hours, 6 hours, 9 hours, 12 hours. So tomorrow we'll have the full 24 hours. I suspect it'll look very similar, but will stretch farther. This morning when we cut out at 6 a.m., we cut off the Perseus arm. Oh, I'm already sleepy. It does look like a histogram of sorts, which it really is. These are the frequencies, these are the magnitudes, and this is the time. 3D only as a function of time. Good evening, Mike. Were you guys impacted in New Jersey by the hurricane, by the water? Many on the East Coast had a rough day. Hello, Ragdi. Atlas? No. We're waiting for the end of the month to look at 3i Atlas. Right now it is too close to the sun, setting with the sun in the west. We attempted to capture it late last week without success. But now that we have a new telescope, even though it is a radio telescope, we are guaranteed 2 weeks of cloud and rain. But the radio telescope does work in cloud and rain, so that's what we have. The data, the nice colorful plot that you see in the lower right quadrant is a plot of 12 hours of data from last night. This is the time axis, 0, 3, 6, 9, 12 hours. That is the amplitude or magnitude, and this is the frequency, 1.4 gigahertz, 1.42. And interpreting what we are seeing, the hump on the left, or the peak on the left, is the Cygnus arm of the Milky Way, and the one on the right is the Perseus arm of the Milky Way, which we cut off when we stopped at 6 a.m. So today we're capturing 24 hours worth, starting at noon and going till tomorrow noon, and then we'll process them equally. We attempted to replace the Sobird Plus H1 from New Elec, that is the low noise amplifier at 1.42 gigahertz, replaced it with the GPIO, and it did not work as well. It had couple of spikes that I could not get rid of and could not understand. So I went back to the New Elec. The other thing that we have now is a box, weatherproof box, to enclose the electronics outside, so the rain will not get in. Mike, do you know anybody in your neighborhood who has an 8-foot C-band dish that they're willing to donate or sell? That's something else that we discovered recently. We have had 2 leads. In one case, it was a Craigslist listing, and when we asked when we can pick it up, they ghosted us. And Steve found a neighbor of his who has a dish, and they don't want it. And when we asked when we can pick it up, they ghosted us also. Hello, CGD. Apparently there are lots of them on Long Island for some reason. I found 3 already there, but I have no desire of pulling a trailer or driving a truck through New York City or a van to go pick up an antenna. No, thank you. I've been searching satellite imagery and street views, looking for a dish to see if I can find one in my town, in my neighborhood. Next step is to contact the TV stations, and I started with our local Channel 9 to see if they have any. I may just have to drive to the TV stations and see who has a dish sitting, being used as a flower vase or plant pot or whatever, and see if we can get it from them. Apparently a bigger dish will probably be the only thing that will make this peak higher. Uh-oh, there we go. Some of you may have heard my story about the tariffs. There's a Chinese company that makes them new, and they sell them at about $840. But with the tariffs, they lowered the price to $149 and changed the shipping from $70 to $700. This way the tariffs are only charged against the $149, and the shipping is not subject to tariffs. But right now I'm not ready to order a new one from China and wait and see if it ever gets here or not. There is also a supplier in Canada, and they say they'll ship it to me. They have no idea what the tariff will be on any given day, and that when the shipping company delivers it, they will expect payment for the tariffs there and then, and the merchant has no idea and no way of telling me what they will be. Hello, Zena. Zena, I plan to be on till 9-ish my time, which is dinner your time. Just to verify that we already have the hydrogen line, waiting for it to pass overhead. We're very likely, next test will be changing the angle of the dish from looking straight up to putting it at 60 degrees and see if that impacts the signal too much. Because the only way we're going to get the Sagittarius, which is the center of the Milky Way, there is the center of the Milky Way. The only way we're going to get it is to point the dish lower, because it's never going to get higher than 20 degrees. It is way south of us, and 20-degree altitude is the highest it's going to get. So if we just stare up to the zenith, we will not see it. Professor Pettit, who has been counseling and advising me and mentoring me on getting into radio astronomy, recommended using a two-dimensional plot instead of a 3D. And if we are to go the 2D route with the same graph, uh-oh, that's not what I want to do. All right. File, open. That's what it looks like. He recommended the standard Z view. Not much has changed. Uh-oh, okay. Yeah, I don't like it much. So we're going to go back to the 3D. And that's what we get. Yes, and that is the plan. The dish has a main lobe of about 30 degrees. I intend to mount it eventually on the Ioptron AS Pro mount that I have, and point it towards specific stars in the Milky Way. For example, Deneb right now is here, Altair is there, etc. So we should be able to point it, and then it will track the Milky Way as it moves and collect the data. Putting a mount under the dish is going to be a whole other world when it comes to RFI. Some of the surprises that we got the past few days, the biggest surprise by far is that the monitors, the computer monitors that I'm using, create enough RFI to interfere with the signal. That was not as much of a surprise as the amount and the pattern of the RFI is a function of what's being displayed on the monitors. When I changed the background, the signal went totally berserk. And we also learned that calibration, or taking darks, if you will, and that is measuring the background noise so we can subtract it from the actual signal. The initial recommendation was to put a 50 ohm terminator on the cable, disconnect the antenna, and take the darks that way. The same way as you do with a telescope. You cover the lens, you take the darks, and then you uncover it. It turned out we were far better off doing it with the lens uncovered, because the antenna was picking up all the junk that we did not want, and not so much the sensor itself generating that. So now at noon each day, when the antenna is pointing to an empty part of the sky, Jeff, I may need to do that. Alex Pettit mounted his dish on a Celestron computerized mount and did not seem to have a problem. Yeah, covering it with aluminum foil and grounding the foil may have to be the way to go. Jeff, don't know if you saw the 3D plot of yesterday's data. The two peaks here are the Cygnus arm and the Perseus arm of the Milky Way. Cannot interpret at this point the colors as Doppler effect. Right now the colors here are magnitude and not frequency displacement. Jeff, one thing I like about the AS Pro is it will self-calibrate, and it'll be close enough. By leveling it, I can just turn it on, have it go once around, and then tell it to point to whichever part of the Milky Way I want to point at. And then if I have to turn it off at this point to eliminate the RFI, I can turn it off and let the Milky Way pass in front of it. It's going to depend very much on the weight of the dish. Mike, one thing that we did not add inserted, we'll wait for the ads. Mike, I was about to say that the hydrogen radiation is not polarized. However, the noise around us is very polarized, and I noticed that by rotating the dish by 90 degrees, it made all the difference in the world in terms of the noise that I was picking up. Right now, my AS Pro is retired also. I had put the Celestron Edge HD on it. I got it used as a stopgap to see how well it will work when my CGX mount, when the motorboard died, literally. And the folks on the West Coast have a lot of 8-foot dishes that they're trying to get rid of. Jeff, I tried the GPIO LNA and it did not do what I wanted to do. It was a lot noisier than the Sobird Plus, so I put the Sobird Plus in. I was hoping to put them together again in a row to get an extra 6 dB, but that's not going to happen until I figure out why it is so noisy. I can certainly 3D print a dish. We're going to have to find a way to cover it with metallic stuff. Can I 3D print with metallic material? Yes, you can 3D print with metallic materials using specialized printers that use processes like laser melting and sintering on metal powders. This already sounds expensive. Yeah, it's going to have to be copper mesh. That is very doable. Right now we have a solid lead about 20 miles from my house. I have not seen the dish yet. But we will see. There is a guy in West Nyack, New York. He posted a picture of the dish on his roof and said, if you remove it, you can take it for free. I don't know if West Nyack is considered far enough from New York City. It's not too far from the NEAF, the Northeast Astronomy Forum, each year. So the next big step for us is to put the dish on the AS-Pro mount and try to hit those areas of the Milky Way, see how different they look from this, and then start exploring the length of the Milky Way while keeping all the data so we can eventually plot the entirety of the Milky Way. Vivant, I'm going to start with the advantages. We can use it when it's cloudy and rainy. What a radio telescope does, this particular one operates at 1.42 gigahertz, so it is a wavelength that is 140,000 times longer than infrared. So it's looking for much wider field of view. We're trying to detect the emissions from neutral hydrogen that occur when an electron spin flips. A hydrogen atom, a neutral hydrogen atom, has one proton and one electron. They are spinning either in the same direction or opposite direction. And every 10.3 million years, if Jacob were here, he will tell you it is 10.2, I think it's 987 or 789, whatever. But every 10 million years, the electron spin flips, and that creates a tiny amount of radiation. Since there are 10 to the power 57 hydrogen atoms in the Milky Way, about 10 to the 50 of them are flipping every year. And that is what we are trying to detect, the radiation from the neutral hydrogen in the Milky Way. With a dish, antenna, low noise amplifier, and the software defined radio, we are able to detect. This is the signal, and this is the fast Fourier transform of the signal, and that is the hump that we're looking at. Yesterday, for about 12 hours, we stored that data every 15 minutes, and that's what it plots like with post-processing, showing, in this case, Cygnus and Perseus. Perseus is one of the major two arms of the Milky Way. and Cygnus is a minor arm of the Milky Way. The how we plot it is a matter of really preference, whatever you like to plot it as. Let me show you one other thing, and that is the setup. This is the software-defined radio and the low noise amplifier, and this is the dish. That is the setup that I have right now, except it's a bit darker outside and equally cloudy. Right now the dish is pointing straight up, 10-pound barbell to weigh down the tripod, and this is the cable going in. So it is pointing straight up, and we're starting to see the hydrogen line detected. Jeff, I do not have a binocular mount for the AS Pro. Hi, Tariq. So Vivant, the main reason we're getting into radio astronomy is that the program in Oswego, the physics program, has a they're starting radio astronomy activity. So I found it useful to learn up on it and try to contribute. Hi, Bill. Bill, we're capturing 24 hours worth of data today. Started at noon, we're going through noon. One big disappointment today is that the GPIO LNA was way too noisy to be usable. So I have to do some separate testing on it. And we're resigned to the need to tilt the antenna from pointing straight up. Otherwise, we'll never be able to image the Sagittarius part of the Milky Way. Tonight we're aiming straight up. I plan to be live till about 9 o'clock and then let it capture on its own the following 15 hours or so. It has been capturing for 9 hours now. But the plan to build up a map of the entire Milky Way is to start moving the antenna gradually lower and lower so we can get the entirety of the Milky Way eventually. You're welcome. And if you're not subscribed, please subscribe, Vivant or Vivante. And true to form, it has been cloudy and rainy for the past 3-4 days now. Oh, Jeff, I've already fabricated an attachment that allows me to mount the antenna onto the AS Pro mount, so that when it's pointing straight up at rest, the antenna is pointing straight up. Yeah, I've already tested that. The AS Pro has one disadvantage: I cannot leave it out in the rain. So I'll have to be bringing things in and out. I have ordered a new 1-meter dish that is a lot lighter and built specifically for the 1.4 to 1.6 gigahertz range, and the horn that comes with it has a built-in LNA for 1.42 gigahertz. That is going to be about 2 pounds total, the whole setup. So that will be very, very maneuverable, and that'll end up being on the mount. Right now, the one that I have is a little bit cumbersome to move around, just a touch heavier than I'd like it. And the graphic, for those who did not see my short 3-minute video, I will go over it with you. The data that we captured yesterday, that's what it looked like. 48 files worth at 15-minute intervals, 12 hours worth. And each of these files consists of a frequency and an amplitude. The first step was to take all of those files and convert them into one spreadsheet. And that is the spreadsheet. 4 different spreadsheets, but that's the one that I ended up using. And to display those spreadsheets, we use free software that allows file open, and you go to those spreadsheets. That's the first one, which I had not shown before. Not as pretty. It shows a nice break in the middle. And I'm not sure exactly why or where this came from, because it does not appear in the other graph. This is stacking the two graphs on top of each other. Hi, Robbie. The graph can be rotated to your heart's content. It is showing the slices here, 15-minute slices. Uh-oh. Okay, we'll go back. I'll have to find out what 1 point is and what MXB is, and since both are derived from the same data, Not sure what we had right in the middle there. But I'm reasonably confident when I reopen the other file. These two peaks correspond very much to when Cygnus was overhead and when Perseus was overhead. So these represent the two arms of the Milky Way. Perseus is one of two major arms of the Milky Way, and Cygnus Orion is a minor arm. Our solar system is in this minor arm. That's why we get Cygnus overhead a lot. Alan, right now I'm struggling with two conflicting pulls on me. One, to spend a lot of time learning, and two, to get things done as quickly as I can. I'm a firm believer in when all else fails, read the manual. Fortunately, Professor Pettit has been extremely patient and helpful, and I've been shooting him things, and he has been giving constant advice and fast forwarding through the learning curve. So tonight, this is part of a 12-hour capture. Started at noon, it will end at noon. If you'll excuse me, I will be right back. Hi Toast. Continuing from where we left off, my new challenge is to automate the process. So what we're going to do now, the files that we have captured so far today, we're going to run the average on them. It's a Java app. Choose the directory. One star. Sarah. Are these today? Yes. Okay, we made a minor mistake. Let me clean up the files quickly. These do not belong here. And these are the files we started at noon, every 15 minutes or so. So we have 30 files so far today. All right. Choose directory. Hello. Not happy. Let's launch it again. There is the Java file. Choose directory. We're going back up. One star. Sarah. Open. And now we can process. Successful. Okay. Close it. Now we go to the plot. File, open. And here they are. That's the first one. And as you can tell, from noon onwards until we started approaching the zenith, until the Milky Way started approaching the zenith, there was nothing, just ground reference. These are the 15-minute slices. And now we're starting to get to the Milky Way. That is the Cygnus arm. So I should be able to automate this process, reduce them from 15 minutes to 5 minutes maybe, and have it stack automatically and update this graph every time we have an additional line to paint, and then just keep it growing. So that's what I need to get into, finding a way to automate those two programs, the jar, the Java, and, well, actually both are jars. Both are Java programs. And I just need to find a way to automate them. So with every capture, call them again and display the updated file. Then we'll be able to watch here the Milky Way as it's being created as the evening progresses, or the morning in our case, because it doesn't have to be dark, doesn't have to be clear skies. Jacob had asked the question about our friend at 1419.955 as to whether that spike will go away if I changed the frequencies that I'm looking at. It did not go away, so it is not an internal artifact, but it is indeed coming from somewhere out there. Bill, we have Y, X, and Z. I may have mentioned that Professor Pettit recommended displaying it in 2D. Same graph. Looks like that. I don't like it, so we go back to 3D. I'll have to find out what 1 point is versus MXB. This is the frequency, Bill. X-axis is frequency, indeed. The 1.42 gigahertz. The Y-axis is the time in hours. We started at noon, and we are just after 8 p.m. So that's how many hours worth it has captured. And the Z-axis is the magnitude. Z or Z, depending on which side of the Atlantic you are. These are the slices. And yeah, I need to find out the difference between the 1 point and this one. So the bat is basically calling another batch file, ring3d.bat%1. So we should be able to pass the file name in the argument. It's calling another bat. Default options, memory file name, encoding file, software name, software directory, path file, downloader, handles. So I should be able to pass the name of the file there. Okay, And now we just need to find a way to call that batch file every minute or every 5 minutes, whatever long we are stacking at the time. Probably. I found out something interesting today, Bill. One of the new assistant professors at Oswego, who is trying to get the radio telescope, did a postdoctoral stint, I don't know how many years, at Green Bank Observatory in West Virginia. So I'm going to try to find out more. Somewhere I had the names of the people who developed the two pieces of software that I'm using, and it's only proper to give credit where credit is due. But I misplaced their names. Rinearn was written by a gentleman from Japan. I turned the waterfall blue for you, Toast. So we're hiding the waterfalls. It's all about the noise. It's there. Space radio astronomy. There we are. It's Fumihiro Matsui who wrote the Rinearn graphics, and Jamison Adcock wrote the software to convert the IF average to CSV, and Dan Kaminski wrote the IF average for the AirSpy SDR. So I shall edit the description on this video and give credits where credit is due. Credits. Hardware. Hardware is LX Pettit. IF average. Then Kaminski. Java. Jamison Adcock. And last but not least, Rinearn graphics, Fumihiro, Matsui. Okay, I have saved all those names in the description of this video, so you should be able to see them, and if you want to get any of them, you should be able to get them. And there is a GitHub if anyone is interested. Everything that you need and everything that you don't need but did not know that you don't need is in that GitHub repository. Yeah, if you start with the README file, it talks about everything that you need, and then there is a very detailed PDF, extremely detailed, that goes through multiple ways of building a radio telescope and how to use the software, and all the software is there. As I mentioned a bit earlier, I'm being torn between going as fast as I can, generating this stuff, versus reading the 1.42 million files that are there describing everything we need to know. And there is a file called known bugs, which I skipped. And if you just search for LX Pettit on YouTube, there are lots of videos under SARA, the Society of Amateur Radio Astronomers, in which he describes in gory details how to build things and how to tune them and how to improve them. And for some reason, we're trying to get some serious noise on the FFT. I don't know if it's that display here that has upset the RFI coming from the 4K monitor. So our attempt to put two LNAs back to back did not work. So now I'm waiting for the new dish to come. They said they are shipping November 7. That new dish is called the Discovery dish. If you go to crowdsupply.com and scroll a bit down, you will find the Discovery dish. I don't know, Bill. I'll have to look into that. I joined Sarah, so I am on their mailing list. They had a monthly online meeting via Zoom. May have been last weekend, the first weekend of the month. But I don't know if they have... I take that back. Yes, they have two regional annual meetings, one on the West Coast and one at Green Bank. I'll have to find out the dates. This is the Discovery dish that I ordered. It is a lot lighter than the one I have, and it should be more directional. Their Eastern Conference is indeed at Green Bank, Bill, and their Western Conference is in New Mexico. It should have a better signal because it was built for the 1.4 gigahertz to 1.6 gigahertz as opposed to the one I'm using that was built for Wi-Fi. Plus the feed has an LNA in it. This is the link to Sarah, and in it they have, you don't have to go too far to see the Eastern Conference and the Western Conference. And like every professional society website, it is not maintained. It's not up to date. They still have the 2022 to 2023 schedule of events. So their Eastern Conference was June 7 through 11. That one is a drivable for me. And when was their Western? And their Western was in March. So March and June. I would think so. Right now I am scheduled to take a tour of Green Bank in December. Including a high-tech tour that is a very small group tour with their engineers who explain how things work. Salut Etienne. We have captured another one, so let's see if we can just do the stacking quickly. It's getting very noisy for some reason. Okay, successful. I don't know if we can just click process every few minutes or not. And there is the graph. So this is the latest. And it is obviously building the Cygnus arm of the Milky Way. Toast, are you using a flip phone or rotary dial at this point? while Bill and I advancing in, I'm not gonna say age, but stature, keep getting bigger and bigger monitors. Many of our subscribers keep going to smaller and smaller screens. Indeed, Bill. Party line. It appears that those conferences, both the Eastern and the Western Conference, have a virtual component via, looks like Zoom. But I don't know if that includes a tour of the facilities or not. So I want to see if it makes any sense to store those files a lot more frequently than 15 minutes. And if I can automate those 2 Java calls, this one, can I hit process repeatedly? It says successful, and if it says successful, can I reopen it? File, open file, clear, open, same file, open, plot. So in theory, we should be able to automate that into a batch that runs every few minutes. CGD, the first answer is a lot. What I remember right now is that the main lobe will go from 30 degrees down to 4. So if that's any indication, we're talking about probably 8 times. How much more gain does an 8-foot dish give over a 3-foot dish. It says it gives an additional 8.5 dB gain. The gain of a parabolic dish is proportional to the square of its diameter. So same as glass. So it's a function of the square. So it's the total surface that is reflecting and focusing things onto the feed. Alan, this is not a joke. We launched our own satellite, and it was in orbit for several months. Actually, we piggybacked on one of SpaceX's launches. They had a university program, and they allowed us to launch our satellite, and we watched as it got ejected, and we were able to talk to it. Actually, it talked to us. But I was unable to get it to do any useful astro work for me other than creating trails into our images. Toast, yes, that is the main lobe. Alan, that thing was the size of a Kleenex tissue box. It was about 4 inches by 4 inches by 7 or 8 inches in size. We did not have solar panels on it. It had a battery, and when the battery ran out, that thing did not have any jets or anything to adjust and maintain altitude. It was just kicked out. One of the programs that the International Space Station does is they launch satellites from the ISS simply by throwing them out of the window. But ours had slightly more dignity by being mechanically tossed out of a SpaceX Falcon 9. It was a microsat. Bill, yeah, it was S-band. Actually, by the time I retired, we had purchased a new satellite that we were building and configuring, but it never got into orbit. Yeah, engineering is fun. So next time I do the background calibration, I have to do it with those windows open, because they seem to be creating all that junk here, which was not there before I opened them. So that is how sensitive the antenna is. I'm going to have to put some aluminum foil around all the monitors now. Okay, we have a new file. So if we just click process, done. Clear, it did not clear this at all. Edit, clear. Okay, file, open. So we should not have cleared this one. Okay, because it's still the same file name and plot. So the only thing that has changed is this number here, and we have a little bit more. So if we do edit, clear, and then open, plot. All right. Yeah, Toast, right now my big limitation is that the dish is pointing up, which means it's picking up lots of things from the house next to which it is sitting. On the list of things to do is to mount it at 60 degrees, fixed initially, so we can instead of being limited to this location, will be at 1, 2, 3 right here. We can turn it this way or sit there and still watch the Milky Way go by, but a different part of the Milky Way. The following step, and that's when the smaller dish arrives, is to mount that one on the AS Pro and be able to point it to any location in the sky where the Milky Way is at any given moment, and then image it there. We'll see. Build the 15-minute slices were driven by the FFT. The fast Fourier transform is collecting 900,000 samples, which translated into roughly 900 seconds. And to go faster than 15 minutes, we will have to either make the FFT resolution a bit lower, and so 512 samples will have to go down, or dynamic averaging, do it faster than 900,000 samples. That's how it came about. Alan, if you're talking about this graph, the x-axis should be straightforward. It is the frequency. So it is the frequency. And the z-axis is the magnitude, amplitude. And then the y-axis is the time slices. So each one of these slices is nothing more than that. That top curve is what's being displayed here. And as that top curve starts getting bulgy, there is the bulge. CGD, I'm gonna have to revert to my second language and say je ne sais pas. I don't know if I can have Stellarium display H2 as opposed to visible. I will look into it. Bill, I don't know if you have a context for the size of and the layout of New York State, but I asked Gemini AI what is the halfway point between Pompey and Green Bank, and it answered that the halfway is Binghamton, New York, because it's equal distance to Pompey and to Green Bank. Never mind the fact that it's about 6 times farther from Binghamton to Green Bank than it is to Pompey. But for some reason, that's what it came up with. I've been using Grok and Gemini AI quite a bit. And while Grok takes a lot longer, it seems to be giving slightly better answers or slightly less incorrect answers. So, ladies and gentlemen, as I promised, I have a big day ahead tomorrow, so I'm gonna get some sleep tonight. I'm going to turn things off. It will keep capturing in the background, and tomorrow I will have a 24-hour plot for you in a short video. There is an outside chance that tomorrow night the sky will be clear. So we'll go back to traditional optical astronomy and see what's happening in the night sky. And if it's clear early tomorrow morning, don't know that it will be, we'll take another quick look at A6 Lemon. Is it going to be clear tomorrow morning? Negative. It's going to be cloudy till tomorrow evening. So if it's clear tomorrow night, we'll definitely have a glass telescope out. And if anybody is watching and not subscribed yet, please subscribe. We will see you guys tomorrow night, definitely with one telescope or the other. In the meantime, so long from Pompey and from the Milky Way. Don't know if you guys can hear the helicopter, it's very close overhead.